Laws of exponents are important rules that we run into when we have expressions that have exponents. If you'd like to add and subtract terms that have exponents, it's important that you first check to see if they're like terms. Here's how you do that. It's all about the variable part of the term. These are exactly the same variable and exponents, so these are like terms. This is positive 1x squared, take away 4x squared, which results in negative 3x squared. Here, we don't have like terms, and we cannot subtract this. There's no simplifying that you can do at all. In the final one, some of these are like terms and some of them aren't. Here we have xy squared and xy squared. So that's negative 8, and then the variable part stays the same. The other two terms, you just keep them the way they are. Don't make any changes, and that's as simplified as that can be. So that's adding and subtracting. You've got to have exactly like terms to combine anything that is added or subtracted. Next is multiplication. We don't need like terms here because a term is multiplication already. Here's what I mean. This is 3 times x squared times 12 times x to the third, which is also, because of the commutative property, just like 3 times 12 times x times x times x times x times x. So this is 36 x to the 5th power. Now if we look back at our original problem, we can see the 3 times 12, and that made 36. How does x squared times x to the third make x to the 5th? Sure looks like we added the exponents, doesn't it? You're right. That's one of the laws. When you're multiplying terms together with variables raised to exponents, you just add the exponents if the variables are the same. Okay, let's try one more. This is all multiplication also. So we're going to do negative 7 times 2 times 5, which is negative 70. Now let's add those exponents. What's this? We've got a negative exponent. I don't know if you've ever seen that before. We just treat it the same way as the other exponents. So 2 plus 8 is 10. 10 plus negative 5 is positive 5. So this is negative 70 x to the 5th power, and you are done. So the rule is, if you're multiplying terms with the same variable but different exponents, or the same exponent, you just add the exponents. That's how multiplication works. How about division? For division, what we've got is 6, which is like 2 times 3, times 9 of those x's. And in the bottom, I've got a prime number, 2 times x times x. All right, let's see how much reducing we can do. Well, we can divide 2 out of both of those. We can divide x out here, and we can divide x out again because we have so many factors of x. What's left? 3x to the 7th power. So looking back at our original problem, 6 divided by 2 was 3, so we just reduced. How about the x to the 9th and x to the 2nd? Looks like we subtracted, right? So the rule for division is to subtract the exponents. This is only going to work if the variable's the same. All right, let's try the next one. If we divide here, negative 12 divided by 3 is negative 4. And 3 minus 7 is a little weird, isn't it? That looks like negative 4x to the negative 4th power. And what is that supposed to mean? Well, let's look at it the long way and see if we can make sense out of this. Okay? So we've got negative 4 times, and I've got x times x times x over 7x's in the bottom. Okay, let's reduce everything we can. All right, what's left? So this is what that means. If you get a negative exponent, it belongs in the denominator where it will be a positive exponent. And that's going to happen anytime you have a variable in the numerator and the same variable with a larger exponent in the denominator, right? And that equals y to the 5 minus 11, which is negative 6, which is the same as 1 over y to the 6th. This is a simplified answer. We do not leave answers like that. So no negative exponents in the answer, please. And finally, we have variable expressions with exponents that are raised to more exponents. So what are we going to do with this? Well, keep in mind that this means this entire expression times itself 3 times. Let's use our previous rules to simplify this. So since it's all multiplication, we can use the commutative property to skip over and multiply the numbers. That's 125. Now, when we multiply the x's together, remember the rule is to add the exponents. So that's 6 plus 6 plus 6, which is 18. And similar with the y's, we've got 2 plus 2 plus 2, which is 6. Pretty simple, but let's look back at the original problem and see if we can come up with a law for this. So 5 to the 3rd power is 125. That's pretty straightforward, right? Then we have x to the 6th to the 3rd, and that made x to the 18th. Looks like we multiplied. Let's look at the y's. We had y squared and we raised it to the 3rd power. Again, multiplication works to produce the right result. So the law for raising an exponent to an exponent is to multiply the exponents. Let's try another one. How about negative outside of parentheses 3x to the 4th to the 3rd power? Well, that negative is still going to be in front of our answer, and then we raise what's in the parentheses to the 3rd power, but the negative is separate. Okay, so we've basically got 3 to the 3rd power, which is 27, and then we have x to the 4th to the 3rd, which is x to the 12th. You just multiply them, and we're done. Pretty simple. Okay, last example. Whoa, we've got a negative exponent here, so I need to show you what to do with that. It's actually really easy. Notice also that we have a negative inside the parentheses this time, so it goes along with the 2 when that gets raised to the negative 4th power. Okay, here's what the negative 4th power means. It means 1 over the 4th power. So that's what we're going to do to figure that out. And then we have 1 over x to the 3rd to the 4th also. And that's what you do with negative exponents. It's a reciprocal. So our final answer is just 1 for the numerator, positive 16, x to the 12th power. So those are the laws of exponents that should help speed up many problems.